All right, another question came in regards to 4.1. 4.1 number 10, and I have it queued up right here. It's 1/2 x plus 3/5 y equals to 2. 2/5 x plus 3/4 y equals 1. How we do this? Do the addition method. I think it came up because there's fractions in here, so let's talk about it here. All right, copying over to a little work area that I can work with here. So what we're going to do first is the whole concept here is just get rid of fractions. So we look at the top value here. We think of this little 2 and that 5, and we say to ourselves, common denominator here would be 10. So let's multiply both sides by 10. So technically it's like this. Multiply this by 10 and this by 10. But because we're in systems of equations, what we normally do, we just write 10 right here. And saying, okay, we're multiplying every single thing by 10. And so it's going to be 1/2 times 10. Obviously that's going to be 5x. And if it gets a little bit too complicated, like this next one here, it's going to be 3/5. I know there's a y there, but we're not going to care about the y too much here. And we're going to work with this here. So it's going to be a 1 on the bottom there. How about 5 goes away? That becomes a 2. And 3 times 2 is 6. So 6y. And yes, don't forget this 2 has to also multiply the 10. And we get ourselves 20. Again, what are we doing here? Just getting rid of the common denominator. Or getting rid of fractions here. Sorry, fractions. On the bottom. All right, 5 and a 4. So it looks like we're going to multiply both sides by 20. So let's multiply by 20 here. Off to the side, 2/5 times 20. Again, if you can do that in your head, that's awesome. So that makes a 1, that makes a 4. So 2 times 4 is 8. So 8x, 3/4 times 20. So 3/4 times 20. Put a 1 underneath there. How about 4 goes 1? That becomes 5. And 3 times 5 is 15. And then on this one, 1 times 20 is also 20. Okay, now we got rid of fractions here. Now we can finally go on with the rest of the work here. So now the question is, what should I multiply by to get opposites? So notice this right here, from here to here, was just to get rid of fractions. We were not dealing with the whole concept of systems of equations at all. Okay, now we got to think of, okay, how do we get rid of these things? You can cancel off the x's, that's fine. You can cancel off the y's. My preference probably is just the y's. I'm thinking to myself, 6 and 15, they both go into 30. So that means I'm going to have to multiply this guy by a 5. That's going to give me a 30y particularly. And then I'm going to multiply this guy by 2. It gives me a 30y as well, but I'm going to have to negate that so that it comes out to be a negative there. So now let's try it here. So 5 times 5, 25x. 6 times 5 is 30y. And 20 times 5 is 100. On the bottom here, 8 times -2, that is negative 16x. Negative 2 times 15 is a negative 30y. There's my opposite, as I wanted it to happen. And I give myself a negative 40. So there it is. Now let's work it here. 25 plus a negative 16 is a 9x. That is gone as planned. And let's see what this comes up. 100 minus 40 is going to be 60. So then if we divide through by 9, let's see, I think 3 can go into both of those here. So let me just reduce it at least. Get me 20 over 3. So x gets me 20 over 3. Not fun, because now I have another fraction to plug in. Okay, the other thing we got to consider is this whole concept of which one should I plug into. So you have a concept you can plug into this one, the original problem if you like, top or bottom, but you also have the option to plug it into the equivalent equations that you've made. So those two are here that I just highlighted in yellow. as well as the other ones highlighted in yellow. Any one of those yellow highlighted equations will work just fine for plugging in values. Okay, and you can choose any one. I'm going to choose this one right here. So I'm going to go 5 times 20 over 3 plus 6y is equal to 20. Alright, running a little bit out of room here, but let's see if I can at least put in most of it here. Okay, so in this case I'm going to have to make that into a 1. Nothing reduces, so it's a straight 100 over 3 plus 6y is equal to 20. How do I work with that? That's even a problem area here. So let me first of all grab some more space here. So it's 100 over 3 plus 6y equals 20. Let me write it here. 100 over 3 plus 6y equals 20. Well, let's do exactly what we did before. Let's multiply through by the common denominator. Since I only have one fraction, I'm going to multiply through here by 3 and here by 3. So as the 3 goes into that 100, notice what happens when the 3's are going to be gone. Then I have 3 times this guy makes 18y, and I get a 60 on this side. But notice my fractions are all gone. That's cool. I can work with things without fractions in them. 60 and a negative 100 going to make a negative 40. Alright, dividing through by 18. I think both of them, a 2 can go into both of those here. So how about go by 2 here? How about a negative 20 over 9? And let's see, because that's, I solved for x, I solved for y. I know my x was a positive 20 over 3. Now my y turns out to be a negative 20 over 9. Let's see if that plugged in would actually give us the answer. Alright, so how many solutions do we have? We do have just one solution. And if it is one solution, what is it? Well, I'm going to use my little palette here to put in the values themselves. Let's see what I got here. I got parentheses here to deal with first. Inside the parentheses, I have myself fractions here. So 20 over 3. Get out of the fraction, put a comma there. I got myself another fraction. This time it's a negative 20, and this time over 9. Okay, that looks like how I had it. Save, and let's preview just to make sure. Yeah, positive 20 over 3, negative 20 over 9. All looks good. Let me submit it. Let's see if it is correct. All right, there it is again. Perfect score. Love it. And 4.1, number 10 is solved.